Hi everyone, welcome to today's session on active learning for human label variation. So in this unit we already looked at labels, we discussed why they might vary, we talked about human label variation, which is plausible variation in labels due to subjectivity or ambiguity in the instances, and we talked about active learning, a strategy to acquire new labels in a very smart order to reduce our annotation budget. And today we're going to combine the two topics and figure out what changes in active learning if we actually observe this kind of human label variation. Okay, so there are certain assumptions in classical active learning. For example, there exists a single ground truth label per instance. That the oracle provides exactly this single ground truth without any noise, and that the annotation difficulty or cost is equal for all instances. However, many of those assumptions don't make sense when we face human label variation, and the last assumption that the annotation cost is equal also changes, maybe not necessarily with human label variation, but when we also consider, for example, large language models, LLMs, as annotators, which is used more and more nowadays. Which also belongs to this general topic of how does active learning change with changing settings. And yeah, we're gonna start discussing the changes to the active learning loop. First, distributional measures must be used for optimizing and evaluating the classifier. So when we're here in this step of training or updating the model, as we already discussed previously, if you train any kind of model when human label variation exists, it makes always sense and is important to use metrics that can actually represent this variability. I think it's quite a simple one, but still important to mention. That's why we're starting with that. Then we see the unlabeled data pool and the active learning model are the next steps. And specifically, we're looking at the acquisition functions. So how does the active learning model decide which instance to label next? Oftentimes, the classical informativeness or representativeness samplings are unsuitable. For example, as we looked previously, here you can, for example, label the instances based on entropy, which is an uncertainty measure. And those measures are not suitable in this case because they ignore the option of labeling instances multiple times, and they also fail to process distributional labels. Because, for example, what if the instance that we have is just really that ambiguous? What if this is the real entropy of that specific instance? If we're always just labeling the very ambiguous cases, for example, we don't really help the model to learn proper representations of the human label distributions that we observe. And also the option of labeling instances multiple times is important, because if we can only get like one single label and then directly put our instance in here, this labeled data pool, it can happen that this is actually an instance that's maybe very ambiguous, and we actually need 3, 4, 5 or even 10 votes, or depending on the example, maybe 100 votes to figure out to which class it actually belongs. Also, the annotation process itself as a next step needs to be changed for human label variation, because there it actually matters who provides the label. Is there a minority group, for example, that actually needs to be represented? And And also, for example, now that we can have, for example, LLMs as annotators, we must also decide where is an example where a automatic label from an LLM is enough, and where do we really value the human opinion still. Also, again, the question is, do we only want one single label for the instance? Is that enough, or do we already require multiple labels? And here it's also important to mention that obviously the cost associated with labels from LLMs and labels from humans are very different. And this is something that also needs to be considered as well. Okay. And also, a general problem that we have with human label variation is that it is non-trivial to distinguish true label variation from noise, so from error. Especially when labels can be sourced from both humans and LLMs, it's important to figure out who has what kind of capabilities, what are true errors, and what is true variation that we want to represent. And there is like no common standard already in research how to do that. So this is really an open question, because it's very difficult, if you just observe the variation, to figure out which part of the variation is true variation and which one is error. And this problem is even more severe in an active learning example, because there we really need to figure out, do we collect more labels to reduce an error, or do we collect more labels to represent true variation properly? So this is something to also consider. Okay. We thank the DFG for funding and our copyright. Bye, everyone.